Alright, so first thing we want to talk about is what a matrix C looks like. So it's something like this. You'll see them on the ACT, and it's really just an array of numbers. A lot of times they're used for systems of equations, like if you had 2x plus 1y, there's the 2 for the x, the 1 for the y. It comes up a lot in like computer science when you have huge sets of data. It's a shorter way to keep track of everything, to kind of set it up. We are going to just do some very basic stuff with matrices. That's really all we are going to have time for. So my first question is if I want to make these two matrices equal. So without knowing anything about matrices, you could probably guess and get this question right. If I want them to be equal, what do you think P has to be equal to? -1. So my P is -1. What do you think Q has to be?
0.
Q is 0. X would be?
2.
And Y is 1. In other words, for matrices to be equal, they have to have the same number in the same spot in two matrices. Any questions about that? Okay, so the next thing we can do then is add and subtract matrices. Now you can't add and subtract any two matrices. They have to be what we call the same size. For instance, if I gave you a matrix like this, plus this, there's a problem there. Because this one, if I'm talking about the size, we say it's a 2 by 2. It has 2 rows and 2 columns. This one has 2 rows, but it only has 1 column. We can't add everything because they're not the same size. So in this case, if I told you to add them, you would just tell me no solution because they don't match up. But the one I put up on the board, we can add. So if I want to find A plus B, my answer is going to be a matrix. The size of the matrix, how many rows do both of those have? Rows are horizontal, so they have 2 rows. How many columns?
4.
And 4 columns. So they're both a 2 by 4 matrix, so we can add them. We just add the corresponding spots. So 2 plus -3. Let's go down that first row. 4 plus 4. 8 plus 0. -3 plus 1. Okay. Second row. 0 plus 6. 6. 1 plus 8 is 9. 2 plus 2 is 4. And 3 plus 0 is 3. So that is my A plus B. Yes?
So you should always end up with the same
Yeah.
columns.
Yes. So whatever size those are, that would be your final answer as well. All right. So far, so good? Okay, so we're going to do a couple different operations on this problem. So, part A, I said 4 times matrix A. So what do you think that means? Yep, take every single number in there times 4. So the size isn't going to change. So 3 times 4 give me a 12. 1 times 4 is a 4. 5 times 4 is a 20. Second row, -2 times 4 is -8. 0 times 4 is 0. 6 times 4 is 24. If I asked you, what's the size of this matrix? When we do the size, we do rows by columns. So how many rows?
3 times 2.
Okay, so this is a 2 by 3 matrix. 2 rows, 3 columns. B. 1/3 matrix C. So same thing, we're just taking each number times 1/3. And it is okay to have fractions or decimals in these. So every number times 1/3, 9 times 1/3, 0 times 1/3, -3 times 1/3, -1, and 6 times 1/3 is 2. What's the size of this matrix if I ask?
2 by 2.
Right, 2 rows, 2 columns. Okay, C. I'm going to make it harder. 3A minus 2B. That means I'm going to take the number in A times 3, subtract off 2 times the number in B. So really just like any other expression. So 3 times 3 minus 2 times 4. So we would get 9 minus 8, just 1. Moving down the first row. So next I have a 1 and a 1. So 3 times 1 is 3, minus 2 times 1 is 2, 3 minus 2 is 1. Do I need to write out where I'm getting these numbers? Do you guys understand? 5 times 3 is 15, minus 2 times 0 is 0, 15. Okay, second row. -2 times 3 is -6, minus 8 times 2 is 16, so -6 minus 16. Okay, 0 times 3 is 0, 1 times 2 is 2, so 0 minus 2. And the last one, 6 times 3 is 18, minus 2 times -3. So 18 minus -6, so 18 plus 6.
24.
Any issues with those operations? So adding, subtracting, multiplying by a number, it's not too complicated. You probably could have got all those right even without me teaching you. The multiplying two matrices together is a little bit different. So we're going to start out just taking a single row times a single column. So my row is 3, -5, 2. My column is 3, 4, -5. When I multiply those, I multiply corresponding pieces together and then add all those entries. So in other words, we're going to take the number in row 1 and column 1 and take the 3 times the 3. Okay, then I'm going to take the second entry in each. -5 times 4. I'm going to take the third entry. 2 times -5. And then we will add all of those together. So when you take a row times column, you actually just get a single number answer. So I get 9 minus 20 minus 10. So -21. So when we multiply the matrices, we can't just go through and multiply every position. We're going to take an entire row times an entire column. Okay. So when we do this, we can't multiply any two matrices. In order for the multiplication to work, the number of columns in the first one has to be the same as the number of rows in the second. And then I put up here, if you take an m by n matrix times an n by l matrix, you get an m by l. In other words, if I gave you two matrices, let's say the first one is a 4 by 2 matrix and the second one is a 2 by 3 matrix. The number of columns in the first, remember, first number is rows, second is columns. So the number of columns in the first has to be the same as the number of rows in the second. In other words, we could multiply these two. Then my final answer will have 4 rows and 3 columns. So what we're going to do every time, before we ever start our problem, I'm going to have you write down the size of the matrices. The order does make a difference when we're multiplying here. So if, once we write the two sizes, if the middle numbers are the same, we can multiply them. The size of our answer is the outside numbers. If I flip these around, could you do a 2 by 3 matrix and multiply that with a 4 by 2 matrix? No, because if I look now, the middle numbers don't match. So unlike normal multiplication, order makes a difference here. Alright, this will make a little more sense when we just do one. So we are going to find A times B here. First, we have to decide if we can do the problem. So we're going to look at the size of each. So what's the size of that first matrix?
2 by 3.
2 by 3, 2 rows and 3 columns. What's the size of the second matrix? 3 by 4, 3 rows and 4 columns. So the middle numbers match, so we can do it. How big will my final answer be? 2 by 4. I will have 2 rows and 4 columns. Okay, well, I just got an email that they'll let us know when to dismiss you for the EOC because it's not working. Okay, so what we have to do, this is the number in row 1, column 1, right? It's in the first row in the first column. So that's row 1, column 1. So to get it, I'm going to take row 1 times column 1. Right, so 2 times 2 is 4. Moving down over on row 1 and down column 1. 4 times 4 is 16. Negative 1 times negative 3 is 3. I'm showing all my work here. What do I have to do with those numbers? Add them. So we get 23 for that first number. Okay. So this next entry, this is row 1 still. I'm still in the first row, but it's column 2. So to get it, I'm going to take the first row times the second column. Row 1 times column 2. So 2 times 5 is 10. 4 times 8 is 32. And negative 1 times 1 is negative 1. So if we add those, we get 41. Does everybody see where I'm getting my numbers? I'm just going to keep going through this slowly. If you get bored and think you know what to do, feel free to move ahead. So next I'm doing row 1, column 3. So row 1 times the column 3. 2 times 1 is 2. 4 times 0 is 0. Negative 1 times negative 2 is 2. Add those together, and we get a 4. Okay, now I'm in row 1, column 4. So we take row 1 times column 4. So 2 times 4 is 8. 4 times 6, 24. Negative 1 times negative 1 is positive 1. Add those together, and we get 33. Moving on. Now we're in row 2. So first, row 2 times column 1. 5 times 2 is 10. 8 times 4 is 32. 0 times negative 3 is 0. We get 42. Row 2, column 2. So 5 times 5, 25. 8 times 8, 64. 0 times 1 is 0. We get 89. Row 2, column 3. So 5 times 1 is 5. 8 times 0 is 0, and 0 times negative 2 is 0. So we get 5. And the last one. This is row 2, column 4. So row 2 times column 4. 5 times 4 is 20. 8 times 6, 48. 0 times negative 1 is 0. We get 68. So that is our final matrix. Questions? I want you guys to try one. So here's yours. So we have 2 rows and 3 columns for the first one. Second one is, so the 3's are in the middle, they match. Our final matrix will be a 2 by 2. 2 rows, 2 columns. So the first entry is row 1, column 1. So you take the row in the first times the column in the second. So 1 times 1 is 1. 2 times negative 1 is negative 2. 3 times 2 is 6. And we get a 5. Next we have row 1, column 2. So the row in the first row times second column. So 1 times 2 is 2. 2 times 0 is 0. 3 times 4 is 12. And we get 14. Now we have row 2, column 1. So second row times the first column. So 0 times 1 is 0. Negative 1 times negative 1 is positive 1. 4 times 2 is 8. And we get 9. And then last, row 2, column 2. So 0 times 2 is 0. Negative 1 times 0 is 0. 4 times 4 is 16. We get 16. How'd you guys do? Get it? Let's say I gave you this one. what is the size of the first matrix?
2x4.
Okay, what about the second?
2x2.
So, can I multiply those? No. The middle numbers don't match, so my answer is no solution. I can't do those. Or undefined. Do you guys want to do one more multiplication one? Do we need to, or do you think you got it? You want to do it? Okay. Well, then let's stop there for today. So let's give you your assignment. I posted a handout in Classroom. That's right. It's not book problems. There's a handout posted in Classroom. You have a lot of time to work and ask for help if you need it.